Hi everyone, in this lecture we are going to cover basic array operations. So first of all, let's go ahead and let's import NumPy as np. Then I'm going to create two arrays, np.array. This is going to be our first array and I'm going to say 20, 20, 20. So first of all, we are going to take a look at element-wise arithmetic operations, what they are. So let's create a second array and let's call this b, and the values for this is going to be 4, 4 and 4. There we go. So first it is going to be the element-wise addition, where both of the where one element in an array is going to be added to another element in the other array in the corresponding position. So it has to be in the same position. So the first element is going to be added to the first element, second element to second element, so on and so forth. So if I say a plus b, and if I run it, you can see we got 24, 24, and 24. This is element-wise addition. This is the element-wise subtraction. Here is the element-wise multiplication. There we go. This is the result. We also have the element-wise division, which is incorrect. It has to be b. There we go. So this is the element-wise division. We also have the modulo operator, which is going to return the remainder of a division. So if I say a modulo 3, this is going to return the result, the remainder of the division. And this is also element-wise because all of the elements of the A array are going to be divided by 3 and their remainder is going to be added to another array. We can also apply conditional operators to NumPy arrays. In that case, all the array elements will be evaluated against that condition. So if I say A less than 55, it means that we are going to take a look at the array A and we are going to take a look at all the values. If all the values are less than 55, then it is going to return true for all the values. So if I run this, you can see that 20, all of them are less than 55. But if I say b less than 2, we are going to get false because no value in the b array is less than 2. Let's move on and let's apply mathematical operations on 2D arrays. For that, I'm going to create two arrays. These are going to be 2D arrays. And I'm going to say 1 and 1. Okay, there we go. The other one is going to be, so the first one is 1 and 1. The other one is going to be 0 and 1. Let's just copy this. This is a 2D array. Put it right there, change this to b. So this is going to be 2. Okay, 2 and 0. Let's provide 3 and 4. So 3 and 4. So first off, let's take a look at these two arrays. Let's print them. So I'm going to say print. It is going to be a colon backslash n, which is going to create a new line for us. And I'm also going to copy this, put it down here, and I'm going to change this a with b and this a with b as well. Let's run that. So this is a representation of our arrays. We can see that they are two-dimensional arrays. First, let's take a look at the multiplication for two-dimensional arrays. We are basically going to say a times b. Let's run it. This is going to be the multiplication. Now, for the multiplication of matrices, every element of the array A is going to be multiplied with the corresponding element in B. Now, performing matrix multiplication, the number of columns in the first matrix, which in this case is the A matrix, should be equal to the number of rows in the second matrix B for the matrix multiplication to work. This is just like a simple mathematical rule. So we can also do a dot, literally dot, and we are going to say b. Let's run that. And Okay, so this is the matrix multiplication. This part, this is the matrix multiplication. We can also multiply matrices in another way, and that is using the dot method from the NumPy module, and you're going to pass in two matrices, which is going to have the same result as this one, as that one. This part, A multiplied by B, this is basically array multiplication. But if you want to perform matrix multiplication, you have to do A dot or an NP dot. Now, NumPy arrays can behave like any other data type, or D type for short in Python, which means we can use the augmented assignment operator on array elements. What does that mean? It means that if you want all the elements within the A, they should be multiplied by 4. So let's provide 4. You can do the augmented assignment operator. And now if you take a look at A, let's just put it down there. This is going to be A. So the augmented assignment operator basically says that it is going to be A is going to be equal to the current value of A times 4. So 20 is going to be times 4, which is going to be 80. Why did we get 320? We shouldn't get that. We should get 80. So let me just let's run this. Let's just save that. Let's run it again. It did multiply it again. All right. So it re-multiplied it. So it basically multiplied 320 by 4, which is going to give us 1280. If I run this again, if I run the multiplication again, it is going to multiply it again. So it's 5120. And you know what it actually means. It means that the items within the array, they were multiplied once, so we ended up with 80. We multiplied items of the array A with the array B, and we ended up with 40. That's why we saw 320, which actually threw me off a little bit. That, okay, we have 20. Why is that 320? And then we multiplied 80 by 4, which we got 320. And then multiplied that, 1280, and then 5160. Sorry, 5120. So you have to keep that in mind as well. Now, if I grab the B, and if I say, okay, to all elements, I want to add 11. Let's take a look at B. This is going to be the result. So 11 plus 4 is going to be 15. Let's subtract from all the elements of A. Subtract them by A minus 20. Let's just save that. Let's take a look at A. So it's going to be, you can see that A minus 20 is 5100. We also have the division. So it's double slashes for augmented assignment divided by 3. Let's take a look at B. We do have 5. All right, and now we are going to move on. I know there are a ton of examples, right? That's what I meant in my first lecture when I said that, because it is highly practical NumPy. We need to work through a lot of like tens of exercises and examples. Now, what I would like to do is I would like to initiate a new NumPy array. Like I really want to work with something else. So I'm going to say array. And I'm going to initiate ages. It's going to be 12, 15, 18, and 20. All right. Now, what if you want to find the sum of all the elements of an array? For that, we have a method that is called sum. So you grab that array and you say sum. And when you hit enter, you're going to get the sum of all the elements within that array. You can also find the minimum number. What is the minimum value within that array? For that, you're just going to say min 12. What is the maximum? You're going to say max. You're going to get 20. You can also apply mathematical operations on all elements along a specific axis of an array, all rows or all columns. Now, for that, what I'm going to do is I'm going to create a two-dimensional array, and I'm going to call it numbers. You can see how we are expanding on the idea of these operations. We started easy, and now we are moving towards more and more difficult. So np.arange, let's say we want to create 12 elements, and we want to reshape it. into into an array of 3 by 4, or a matrix of 3 by 4. Let's take a look at that. There we go. Now let's say you want to sum all the elements along all columns. You want to access them and you want to sum them up. What does that mean? It means that you want to basically grab 0 and 4 and 8, and you want to combine them together. You're going to get 12. You're going to get 15 for this one. You're going to get 18 for that one, and you're going to get 21 for this one. So you can do that as well. Now that is going to be across a specific axis, right? So I'm going to grab numbers, and we're going to do the same function, which is sum. In here, we're going to pass in an argument. If the axis is 0, it means that we are actually trying to select all the columns. That's what is meant by axis 0. There we go. So it has selected all the values within a column and has added them and returned them right here. And you might have guessed it by now that if you want to add all the values on in each row, you have to do axis equal to 1. This is going to sum all of them together. So it's like 0 plus 1 plus 2 plus 3, 4, 5, 6, 7, 8, 9, 10, and 11. All of them added together. You can also find the minimum number. What is the minimum value in a specific row, in rows or in columns? You can do that as well. So for that, you're going to say numbers.min, and you get it right. You just have to pass in the axis, specify. So this is going to return the minimum number, the minimum value in each column. So in this column, 0, 4, 8, 0 is the minimum, 1, 5, 9, 1, and then 2, and then 3. And let's grab numbers.max. Let's find the maximum value in each row. So we are going to set it to equal to 1. So the maximum number for this row is 3, for this one is 7, and for this one is 11. With this, our lecture comes to an end. See you in the next one.